The specific heat is defined as the amount of heat that is necessary to raise the temperature of 1 gram of substance by 1 degree Celsius. The units of the specific heat can be joules over grams per Celsius or calories over grams per Celsius. We are going to calculate heat with the following formula. Heat is equal to mass, and the units of mass are given is going to be in grams, times the specific heat, and like we say, joules over grams per Celsius or calories over grams per Celsius. And the temperature change. What is the temperature change? Temperature change is going to be delta T. It's going to be the final temperature minus the initial temperature. The units of heat, or Q, are going to be either in joules or calories, depending on what type of units we use for the specific heat. Different substances have different values of specific heat. For example, metals have very low values, and then as we move to water, has a very high value of specific heat capacity. That's why water is used in many things as a substance that will help to cool down. For example, in the cars or in the radiator and things like that. Let's do the following problems together. What is the specific heat of a metal that is 24.8 grams and it's absorbing this many calories of energy when the temperature goes from this to this? So the first thing that we can do is calculate delta T. It's going to be the final temperature minus the initial. Delta T is 4.3. Then we see heat is equal mass times specific heat times delta T. We have heat, we have the mass, we have delta T. So now we need to solve for the specific heat. Specific heat is going to be Q over mass times delta T. We substitute here, Q is 65.7 calories over the mass, which is 24.8 grams, times delta T, 4.3 Celsius. And then we do the calculations, and we get that the specific heat capacity is equal to 0.62 calories over grams per Celsius. Let's work on the second problem. Second problem is saying ethanol has a specific heat capacity of 2.46. They are giving you the energy and they are giving you the change in temperature. The question is how many grams? So we do the following. Q is equal M times delta S times delta T. Delta T is going to be finals minus initial, which is final is 32.8 minus 18.2. Delta T is equal to 14.6 Celsius. Then we're going to solve for the specific heat. This time we're solving for mass. Mass is going to be Q over specific heat times delta T, and then we substitute. Specific Q is 655 joules over specific heat is given 2.46 joules over grams per Celsius, and delta T 14.6. And then we do the calculations, and we get that the mass is equal to 18.2 grams. The last problem is reached. We have 9.2 kilojoules of heat. So the first thing is we know that the unit of heat is going to be either joules or calories, no kilojoules. So we're going to convert these to joules. 1 kilojoule, 1,000 joules. So that's 9.2 times 10 to the third. Let's keep it like that, joules. And then they are giving you the mass in the problem. It's 55 grams. And the initial temperature is 25 Celsius, and the question is the final temperature. So we use the same formula. Q equals mass, SH, delta T. We have Q, we have the mass. The specific heat is given in the tables that you will have in your exams all the time. So we can solve for delta T. Delta T is going to be equal to Q over M specific heat. We substitute. Q is, the value of Q was 9.2 times 10 to the third, because we converted it to joules. The mass was 55 grams, and the specific heat capacity of water is 4.18. Again, you don't have to memorize it. It's given in the tables. We do the math, and we get that delta T is equal to 40 Celsius. The question is, what is the final temperature? So we know that the initial temperature was 25. The final temperature is going to be 40 plus 25, which is equal to 65 Celsius. These formulas that we just discussed are used in food, energy, and nutrition. Calories of food are determined by placing a sample in a calorimeter like this. The sample is burned, the heat is emitted, and the water changes its temperature. And they record the temperature, the change in temperature, the mass of the water with its specific heat is proportional to the amount of heat produced by burning this substance. So there are tables here, like for carbohydrates, they have 17 kilojoules per gram, fat 38, protein 17, and we could do calculations like how much energy is in a cup of milk. So that's what we're going to do. So we have a cup of milk, and we want to know how many calories are in there. So in order to do this, we use the tables that were provided before. You don't have to memorize that. So we have 12 grams of carbohydrates, and then we do a conversion. Grams goes here, kilojoules here. Say per 1 gram of carbohydrates, we get 17 kilojoules of energy. Convert joules to kilojoules. Say 1 kilojoule equals 1,000 joules. Then convert into kilocalories, right? So we have, we're going to convert from joules to calories. 4.18 joules is 1 calorie. And then we need to go to kilocalories, which is 1,000 calories equals 1 kilocalorie. 1,000 with 1,000 cancel out. So the answer for this part is 48.8 kilocalories. Then we do the same for fat and protein. We do 9 grams of fat, and then we use the table. 1 gram of fat, 38 kilojoules. Now, kilojoules to joules. Joules to calories. And calories to kilocalories. Do the calculation, and the answer for this part is 82 kilocalories. And then we do the calculation for protein. 9 grams of protein times 1 gram, 17 kilojoules. Kilojoules to joules. Joules to calories. And calories to kilocalories. And the answer here is 36.6 calories. So, in order to finish the problem, you add the calories from carbohydrates, the calories from fat, and the calories from protein. So 48.8 plus 82 plus 36.6, and the total answer is 167.4 calories. And this is uppercase calories, or which is also known as kilocalories.